So Linux kernel internal. This is a theoretical class. Next sessions which we'll have will be some demos for the Docker. So in this session we will primarily discuss only four things. Okay, what is kernel? Okay, why do we need it? What is the functions of it? And some of the internal components of it. That's all. Because kernel is a very vast component. We will not go into much detail, but whatever we needed to practice on day-to-day activities plus interview, we will cover this one. So what is a kernel? So kernel basically is a program. Simple. This program is written in C. Now the question is, why do we need it? So if you want to understand that we communicate with hardware, right? We communicate with hardware. So hardware means in our case we will have laptop, desktop, mobile devices and all kind of things, right? So these are our hardwares where we communicate. We send some certain instruction and they respond it also. For example, you have laptop, so you have a input, you give it something like from keyboard, mouse, some other form of input. You can, nowadays we are giving like audio and all kind of things. So this is been received by one operating system, and they process and send it to you in form of response. But who will work as a mediator? That is where the kernel is coming up. So if you see that foundation, you have a hardware. Hardware means CPU, memory, disk, and devices. In simple way, your laptop or desktop or mobile. Now on top of that you have a kernel. So again, remind it, kernel is a computer program. It's a computer program which is kernel, and kernel is sitting on top of hardware. And then on top of kernel we have all the user level applications. Now when we say user level application, means whatever you're using, notepad, calculator, browser, you know go to meeting. Now we are using MS Office, Photoshop, and all kind of things, right? So that is kernel. Kernel is a program written in C, which is between the human and then hardware. For why we need it? For interaction purpose. Now where kernel program runs? So basically, uh, this kernel program, the code which you see, you will not see directly, just like you log into operating system, you'll not see, but it will keep running in your memory. Okay, so it is a portion of the operating system code that is always resident in the memory. That means when you install the operating system, each operating system you have a kernel. Okay, you have a kernel over there. So it's resident in the memory and facilitate interaction between hardware and software component. So that is something which we understood. Now when kernel program runs, so simple way, if you start your laptop, okay, that will trigger the bootloader. Okay, the moment you say okay, switch on, something like that. Your mobile also you start, something like that. So first program which get loaded uh, through triggering in the motherboard, which is called bootloader. Okay, so bootloader, okay, which basically trigger the kernel program and run in the uh, memories. So kernel is one of the first program loaded on the startup after the bootloader. Okay, so that is something. Now which are the types of kernel? So we have multiple types of kernels. We have, these are the some of the popular one. So we are most of the time we are using monolithic kernel. Monolithic kernel means the VM which you create or maybe created or you will create in future also, the VMs on AWS or Azure or your laptop virtual machines. Then you will feed the some operating system that will have a monolithic kernel. In fact, my Windows is running with a monolithic kernel actually. This is Windows kernel, but for our training we will use Linux kernel, Linux operating system. Okay. Um, there is a I don't know how many of you know, but mobile also you have a kernel. All of you must be using Android. If not, uh, then they Android is nothing but built on kernel only, Linux kernel. Okay, so these are the some of the type of kernel which you have. So we using monolithic kernel all the time. Okay, now what are the primary roles of kernel? What are the functions of the kernel? Okay, so there are so many important work which they are doing it. One of the work which they are doing is device input and output management. Input means they are taking all of your instruction through keyboard, through mouse, through touch devices, through audio, through video, or printer. All these are input devices, right? So they take the input and give you the output. Okay, so for that, these who's doing that work? So that is done by the kernel itself. Now second work which you see is task management. Okay, task management. So task management, you might have seen it all the time. Let me show you. In Windows also, if you go and here, what is this? Yes. So these all are the task management. You see, these are the task management. So these are the application which is running by kernel itself and managed by kernel. So these are all the tasks you see. If you uh, a little bit go into the mode of understanding, see here. So these are the applications, and if you noticed, each applications which get a PID, process ID, you won't find any application which is running without a PID. And the status is running right now. It can be, you can stop it also. So the moment you stop, CPU and RAM utilization will not be there. Now you see here, all these are 0, 0, 0, 0, 0. That means these are running, but it's not, I'm not using it. So CPU is required only when I use it. Okay, so how do I see that? Where the go to this one, see here, CPU. Now let me take a one more snap. See here, see here. So now these are all the process tasks. Okay, PID. Now here, start with 0 to 4 and followed by all this PID. Here you see CPU allocations is happening. Now, system can allocate the CPU only to one process at a time. Okay, so they keep transferring from here to here, here to here, here to here. So this is something like this. So this is called context switching. I'll discuss in some time. And this is a memory utilization. This is the architecture. Okay, so this all managed by which task is running, how much CPU needed, how much RAM needed, and you see that one important thing: each application which is running is ran by user. Without user, you won't run any application. So this is system. This is Rajesh Kumar, DWM. Different users. So you won't see any task which is running without a user. So this all work, who's doing it? So that is done by task management, I mean kernel. Okay. Third important work which is done by kernel is memory management. Memory management means, see here, which process required how much memory and how much I should give it to the each applications, that who decides it? So kernel will decide it. So this is called memory management. Now sync and communication, synchronization and communications between the process, also between the thread, between the process, between the input and output, all these things is taken care by kernel. Interrupt and event handling also, and timer management also. So yeah, full kernel control all hardware resources, input, output, memory, cryptography, via device driver, arbitrates conflict between the process concerning such resources, and optimize the utilization of common resources, such as all this. Now, Linux kernel. So now we understood that at a high level what is the kernel. So there are many kernels in the world. You will find Unix kernel, then Linux kernel, and then uh, this one, Windows kernel. Do anyone have idea who's this guy? Anyone? Hello?
No?
Uh, I'm audible?
Yes, Radish. No. You can bring the further language.
Yeah. So his name is Linus Torvald. So he's the father of Linux. Okay. So this guy is very important for you guys. Why? Because in a DevOps, SRE, DevSecOps, MLOps, all these things, you will use widely Linux plus Git and more or less other technologies like a Docker also. But Git, he's the father of Git. He's the father of sorry, not Docker. This one. He's the father of Linux also. So Linus Torvald. Okay. So yeah. So now let's focus on the Linux kernel. So Linux kernel is a free and open source. Yes, it's a free. You can go and download the code from the GitHub. You can change and you can create your own kernel. Okay. So now what has happened? Many organizations, they have copied the code from the Linux kernel. Okay, and they have created their own version of Linux. Okay. So now you will hear this Ubuntu. So Ubuntu, what they did, they copied the code, Linux core code, Linux kernel code, and they created operating systems out of it, and they named it Ubuntu. Same thing was done by people Fedora. Same thing was done by Red Hat. Same thing was done by this one. What do you say? Uh, uh, CentOS. So we have more than 40 flavors of Linux. So that all organization, all foundation, they have copied the code from the Linux kernel and extended it. Okay. So someone like CentOS, they put the package manager, additional package manager called Yum, and Ubuntu people put the package manager apt. Okay. So that is a thing. So Linux kernel is free and open source, monolithic, modular, and multitasking. Now, this is Unix like operating system kernel. It was originally authored in 1991 by Linus Torvalds, and the architecture which we have is i386 based PCs, and it was soon adopted as the kernel for the GNU operating system, which was written to be free, liber replacement for Linux. Now, use of Linux kernel. So every day you will use it in a server. I doubt you will use it in personal computer because you may be having Mac or maybe Windows. But Linux kernel you will use for the servers primarily. But your mobile also have a Linux kernel, embedded devices, sane frames, supercomputers. All they use the Linux kernels actually. Okay, so now let's try to get into a little bit of internals of it. So how the system works and how the Linux kernel works. The very first thing when you start your machine, a very first thing which the program got started, which is called bootloader. Okay, so what is a bootloader? So bootloader is a kind of, again, is a code which is residing in your motherboard. Okay, so this bootloader, also spelled as a bootloader or called boot manager, or sometime you call it a bootstrap loader. It depends on the people who using these terminologies, but it is a computer program that is responsible for booting a computer. So see, whether your system is having operating system or not, still you can boot the operating system. That means still you can start that. The moment you start boot this program, bootloader will run, and they'll tell you, hey, we do not find any loading devices or something like that. So loading devices means your operating system mount or CDs, or sometime USB devices. So these are the boot you can load it. So if you have installed the operating system from a scratch, you must be working with a bootloader first. Many people, what they do in one laptop only, they want Windows or Linux, so they install bootloader, created two load devices, and then accordingly they do that. So bootloader is a first component. Okay, so how bootloader works right now, not no need to get into the depth, but just at a high level, the computer first execute a relatively small program stored in read-only memory, that's called ROM. Where is ROM? It's resided in your motherboard only. Okay, and later on that they use that RAM, EPRAM, NOR flash, and stuff like that. So that is where that is running. So a bootloader runs in the ROM. Okay, remember that. So this is the flow. First you power on the your laptop, then ROM code get triggered, and then you have a booting devices including bootloader, after that kernel, and then your rest of the application. So this is the flow. So powered on, load bootloader in ROM, load kernel code in RAM. So if someone will ask you where the kernel code runs, so it is in RAM. So where the bootloader runs, it is in ROM. Will you remember this, all of you?
Yes.
Yeah. So this is a little bit a detailed image. We'll ignore it. We don't want this one. Now we'll discuss about the uh, this image, and this is a very important image. Okay. So here, if you see, bootloader also you have a three phases. Okay, and then after that you have kernel. You look at the image left side, and after that you have a user. Okay, so what is happening? So mind it here, bootloader is also program. Okay, kernel is also program. Okay, and the user application is also program. Okay, so bootloader program is built in motherboard only, the laptop motherboard. Kernel is you will install it through operating system. Operating system has a kernel, so that is also one code. And user code you can write in whatever the language you want: Python, Perl, Java, C, C++, whatever you know. So now there are three areas of the file system. So understand this way. This is a very important image which we need to discuss. So see here. So this is a type of program. So let's say type of program. Okay, type of code. Now this code will consume resources. So when I say resources, what resources? So this code need to have memory, correct now, to run. Okay, so just now we discussed this is this is running in the ROM. To run any application you need a memory. So this is running in the ROM. ROM is built in your motherboard only. Now this is in your RAM, virtual memory, and this is also in RAM. Okay, now so now here this is the code. Understand this. This is the code, this is also code, this is also code. So this all code has to be stored somewhere, right? So this code is stored in motherboard only, and kernel code stored in many different locations uh, under the root locations in Linux. Many locations, you have SBR, this one, MNT, user, many places. I'll show you this one in few times. And then root file system again depends on your wish where you want to store this program. Okay, so always remember these are the primarily divided into three areas. Okay, so here you have a two space, kernel space and user space. So what? So bootloader you understand is built-in memory, but what is kernel space and what is user space? We need to discuss this one. Okay, so understand in this way. Computer OS usually segregate virtual memory, okay, into multiple spaces. Okay, so let's say you have this much of memory. I just said no. I have a memory, let's say 10 GB. Okay, 10 GB. So this 10 GB I will segregate in case of Linux, they will segregate into two area. One is user, one is a kernel space. This is called kernel space, and one is called user space. Okay, divide. So here, a computer OS operating system usually segregate virtual memory into two space, user space and kernel space. Now, so that means you have a virtual memory divided into kernel space and user space. Now, what kernel space is doing and what user space is doing. So let me tell you here, kernel space, whatever the memory allocation happens, perform all the tasks, and the tasks which we discussed earlier also, such as running processes, managing hardware devices, hard disk, handling interrupts, and all stuff like that. Okay, so in a kernel space, all the uh, these applications running. Now user space, what you are running? So user space, you are running browser, notepad, wordpad, audio, video, all this thing you are running. Now, it's very important. There is one keyword which is called protected. Remember, in the kernel space, if you look at my slide, protected. So whatever the program you are running in the kernel space, it is protected. Whereas in any program which you are running in the user space is not protected. Okay. So let's discuss in different way. Understand this way. Use of user space and kernel space. So kernel perform a task such as running all this thing. Uh, just a second. Here. So primarily, why we have a separation of this user space and kernel space? So primarily, this separation serves to provide memory protection and hardware protection from malicious and irritant software behavior. That means what we are trying to say. Understand this way. So here you are running few. This is a you. You are running certain applications. Uh, certain applications. Let's say Notepad. Okay. Now Notepad you will run and you will seek for the RAM and all stuff like that. And maybe if this program is compromised, this program is bad, so you will try to disable the kernel, because kernel is your system which is running everything. Remember that. So you try to destabilize the kernel. So here what is happening, we divided these two program, user program and kernel program, into two space. So you cannot disturb this, you cannot kill this kernel program. Kernel program can kill you, okay, but user program cannot disturb the kernel program. Why? Because kernel program is running in a protected areas, no one can do that. Okay, so that's one of the reason we divided whatever the programs you'll run in the user space or kernel space separately, because kernel space will be separate, protected. Why? So that way your system will not shut down again and again. Let's say
But
some
if we are
program.
killing that program, then it will uh, stop the kernel, right? If we are actually um, stopping the program using a task manager, if you disconnect.
No, there is a, see, kernel will stop only when you, there is a one called graceful and forceful. So forceful means you shut down your laptop forcefully by shutting down the power itself. That is forceful. But graceful is basically is a way called shutdown process. So when you shut down, that is a right way to send the signals. Okay, to shut down your laptop. But what I'm saying, let's say these are the program running here, and let's say this program is running, you see network, that means user program. Network services run by network services is the user program. Now because of certain problems in this program, this program should not send the signal saying that shut down the laptop, because I don't want to shut down the laptop. So this program should not send the instruction to the kernel saying that hey, you shut down. So if you shut down, then system will be unstable because it's not based on your wish. So that is what I'm trying to say. Got it?
Yeah.
So so here, remember that all the virtual memory is divided into two space, kernel space and user space. Okay, kernel space, whatever the program is running, it's managing your entire operating system, and it is in protected area. User space you are running all the programs which notepad browser and all kind of things which you are running and using it. Now understand this way. This is a good image you see. uh, Kernel runs in a supervisor mode and has access to user section as well. Yes, look at this. And application runs in user mode but with limited privileges, but each application has its own virtual memory mapping and stuff like that. That means whatever the applications user is running, kernel has a access to it. Whatever the applications user is running, user user is having access to that, but kernel's applications you don't have access over there. Okay, so that is important. So how it is possible? So that is called kernel is running in supervisory mode actually. Okay, now the question is, understand this way. Kernel space is running all important processes like disk management, input output management, task management, memory allocation, CPU allocations. Everything is managed by kernel space. So now users required certain resources. So now user has decided he will run browser and he will run notepad. He will run PowerPoint slides and all, let's say. So users will say, hey, in order to run the process of the notepad or MS Office or whatever it is, these all are application you can see. So most of these all except system all are running in the user space actually. Okay, look at this. These are all Rajesh Kumar, lots of application running, right? So let's say I'm running the Chrome. Okay, so Chrome, I need a access. For what? I need a resources. What resources? So you need a CPU and RAM. You need four resources primarily. Okay, understand this way. Any process you require four resources in order to run, and this is important statement. You will have to take it in this Docker session also. See, these all applications which you see, in order to run, you need a PID. Okay, so each PID will be each application, each process, each application will have one PID, and this PID will be linked to your CPU allocations and RAM allocations. So that means you need a CPU, you need a RAM, and then you need a user. Okay, see that each applications you have a user. So three, and fourth, you need a PID also, correct? So you need a PID, you need a user, you need a CPU, you need a RAM. So and one more thing, two more things we need it. Basically, this is considered only one. Okay, so two more things is needed, and that is this Chrome is stored in certain places, right? That is called file system. Please remember that file system. This Chrome, when I installed it, it is stored somewhere, right? So that is also resources where storage resources. So Chrome is stored in somewhere in the C program files and blah blah blah, right? So that is also you are consuming, right? So input and output is happening, and you are using the storage. So you need a file system. And one more thing, you need it if you want to access the application from outside, networking. So please remember that always networking is optional. If you want to access that resources from outside, then you need it, else you don't need it. So these are the resources you need it, and all this is managed by kernel. Coming to the point, now the question is, so when user is running applications, they required CPU, they required RAM, they required a disk, they required many other things like permissions and stuff like that. So user space, the application which you are running, they don't have any resources. Who's having all the resources? Who's managing it? Kernel is managing it. Are you getting it, all of you?
Yeah.
Yeah.
Yes.
So here kernel is managing it. So user when you start notepad or when you start up browser or whatever it is, then user space application request kernel space application, hey kernel, give me the RAM, give me the disk, give me the this and that. So now the question is how this request is made. That is the question. This is the most important interview questions. They will ask you how the applications which is running in the user space will request the resources. Resources means RAM, disk, and blah 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 from the kernel. So then you should call it syscall. Okay, system call in full form, system call, syscall. So that is important. So your users, I mean applications running, process running in user space is required the resources which is managed by kernel, and that request is done by syscall. There are hell lot of, so this concept is called syscall, but syscall you have a multiple syscall code actually. Okay, we don't need to go into that because we are not becoming a programmer. But one of the example, let's say you are running bash. Okay, look at this, very simple and good example. Okay, so here you are running the bash is your one application, cmd application, command line application, bash shell. So now when you run bash, you require the memory, correct? Now, so then first thing, here I showed you. Okay, I deleted that. So remember that I told you you need a PID, then you need a RAM, then you need a CPU, you need a this one, what do you say, user, and then file system. All this thing you need it, and then network also in a special case when you want the application to be accessible over the network. So these are the things you need it. So you see here, bash, first of all, first time they will get a they will make a system call, and in a system call there is one function called get PID. So likewise in a system call, syscall code, system call code, there is hundreds of functions are there for everything. Okay, so here in this case they are saying, hey, get the PID for this bash process. Now this all program is running in a kernel space, will get you the PID and then release to PID. Now PID will attach to some CPU and RAM, so again they will ask a CPU, RAM, and stuff like that. So they'll make a request to the kernel space, and kernel space will provide it. Now this is a one example. Second example, let's say you want to open one file. Okay, any files, let's say this file you want to open. Okay, or in Linux I'm talking about, right now I'm showing you the Windows. Okay, so here you will open up one file. This file is located in etc host. So then see, this also permission you required from the kernel space. So now open syscall will happen, and then open syscall will make a call to the kernel space. Kernel space will use your BPS, XFF, blocks devices, and open that file and give you the content. So everything, whatever you are doing, basically you are asking the kernel space to give me the resources through syscall. Will you remember this?
Yes.
All of you?
Yes. Yes.
Yeah. So here you look at this. This is another picturizations here. Hardware, then kernel space, and then user space. Now again, we discuss actually. So I'll just ignore it. Again, you look at it, hardware, kernel space, user space. Kernel space, all the code you have. First is call, file system, inter process communication, input output devices management, and blah blah blah, and applications in user space. This is a very deep dive image which has most of the method which is being used. You don't need to know right now because you are not a Linux kernel programmer actually. Okay, so that is something which we understood. So now, so far what we understood, what is kernel?
Under user
What?
space, there was also libraries, right? Can you explain that as well? Or will
Yeah.
you
So
come
this,
to that?
so these libraries. Okay, I'll tell you. Uh, Understand this. These libraries. Let's say OS. So when we say OS, let's say 1 GB. Okay, 1 GB. Now in this OS, you know what are the things you have? So we have, first of all, you have a kernel. Now kernel most of the time will should not be 100 more than 100 MB. So what is your, you have a 900 MB then? What is a 900 extra MB? So here you have lots of software which is running in the user program. So what are the software? So for example, let me put it in this way. Nowadays everything is automated. Earlier in the older time we used to do that. So libraries means, let's say you will have a network libraries. Now network libraries is a user programs. Okay, so this is one thing. You will have a sound, you will have a what is this, graphics, no, you will have let's say you are using Linux to apt or yum, you know, all these things. You have many drivers, you will have it. So these all you required to work actually the laptop. Right now once you install one package everything is installed, but earlier we used to do separately. So these all libraries plus certain uh, shell will come. Shell means in Windows we have PowerShell or command line CMD. In Linux we have a bash shell, corn shell, C shell, multiple shells are there, corn shells and all kind of things. And then you have a different applications. So libraries means uh, these all foundation applications which is needed for running your laptop, I mean your compute unit, but you don't install it directly. Getting my points?
Yeah.
Yeah. Okay, so now let's discuss about the architecture. So before that, let's revise the stuff. What we learned, what is Linux? Okay, types of Linux. Why do we need the, sorry, my bad. What is kernel? Types of kernel. Why we need kernel? Okay. Then coming back to the Linux kernel, what are the role, what is the function of kernels? And Linux kernel, how the area is virtual memory is segregated into a kernel space and user space, how the application running in the user space make a call to kernel space, and all stuff like that. Now let's spend some time on the architecture. So this image you might have seen in your colleges also while studying the operating system. So here you on top of hardware you have, on top of you have a kernel. Okay, so now how do you make a request to the kernel? How human can interact with the kernel? Okay, so then you will say I'm interacting through notepad or browser. So nowadays this we are doing it. Earlier days we were not doing all this thing, so we were using shell. Nowadays also we are using shell, and you have to become a pro in shell. Okay, so let's say you want to talk to the Linux kernel. So which shell you are going to use? You are going, so see, there's a so many shells are there. C shell we have, SS shell we have, corn shell we have, this one bash shell we have. So in this program, in this art session, we'll use a bash shell. Okay, by the way, bash shell nowadays is a default shell for most of the most of the Linux, but if it is not, you can set it up also, bash shell. Okay, in Windows you have a PowerShell now. Earlier we had a CMD. So here you have a hardware on top of kernel and then top of shell, and after that all the utilities, command line and all. In terms of Linux, you have a so many commands. Okay, so many commands. So here I'm trying to document all the commands, and here, so see here, minimum you will have a 1229 minimum. Depends on your version. You have more. You may have a more also, but sorry. So this is a commands actually. All the commands I'm trying. Now, what is a commands? So don't get confused. Commands is equal to applications. Simple. Okay. Some applications is CLI based. Some application is a GUI based, console based, and some applications are browser based. CLI means, let me show you. This is a CLI. Okay, and what you are seeing my window, my screen, right? This is console, and browser you know very well. Got it? So these all are commands. These all are basically applications, and this application you can use a command. Okay, so remember that. everything is a command only. If you fire anything, console also internally is running commands. You are firing some browser, internally is running commands. Here you are typing anything, internally is running commands. So everything is commands. Okay, it's resided in Windows, resided in uh, this location. C program files, and there's one more locations. C Windows. Where is that? Here it is. So in these locations, multiple executables are located. Okay, so everything is commands. So these all CP is a tool. It's executable, but it's command. Move MB is a tool, but it's command. CD is also tool, which is installed in our Linux, all the Linux, but it is command. Okay, so remember that all these are commands or tools, whatever you want to call it. Okay, so yeah, I think this image is something familiar. You have a hardware, then you have a kernel, and then user. Kernel is running in the kernel space, user is running in the user space. Same image. Now, system calls also, we have lots of specification, but right now you don't have to get into that. Okay, because because I told you you want to become a DevOps or SRE or something like that, but not a Linux kernel programmer. So you don't need to go into that. But at a high level, system call provide the services of the operating system to the user program. Mind it, system call is for the user program via API. Okay, so this is called application programming interface. It provides an interface between process and operating system. Operating system here is a kernel. Okay, so here I showed you one image, right? Some process. See here, this one. So process. So any applications when you start, it create a process. And process, in order to run it, mind it, in order to run it, you need a RAM, you need a disk, all these things. So that is where the system call is made. Okay, so at a high level you understand this way. Okay, so system call provides the services of the operating system to the user programs via API, and it provide an interface between the process and operating system to allow user level of process to request services of operating system. System calls are the only entry point into the kernel. Okay, so these are the types of system call. It's like a function of kernel also. Multiple. Okay, so how system call works, you don't need to know. This is something which is deep diving into this. I'll ignore it. I'm ignoring it, something which is not needed, and we'll go into the yeah. So these are the, if you look at the kernel, okay, these are the main function of it, which I have been telling you from last 1 hour. But out of which there is one important thing is process and thread. Okay, so look at this. Here you have C process PID. See here process and thread. You will not be able to see here, but in Linux I'll show you how to see the thread. So have you noticed one thing? let me let me show you Linux also, one Linux, so it will be easy for me to sorry, one Linux box. I'm showing you. Sorry. So this, I'm sure you may have created the VMs in your laptop, but this VM is in AWS. Okay, so let me start this VM. taking time. So I have a putty. Let me log into these machines. I'm logging through the keys. I don't have a password right now. I mean, I think I should be having it. Oh, I set it up the password, but it's okay. I have used the key already. Ubuntu. So this is the, and I'll become a root. That's my bad habit. You should use the sudo, but that is not good habit. So I'll just make it the view better so you will see that. Uh, good. Are you able to see that screen? Well,
Yes.
yeah. So guys, one thing you should notice, okay, in Windows also and Linux also. That's the reason I open up. So have you noticed your PID here start with 0, and here if you see that PID start with 0. This is the PID, this is the parent ID 0. Got it? All of you?
Yeah.
Yeah. So what is happening? Understand this. So what happens? Uh, there is one called PMAP. Okay, PMAP concept. So whenever you start your computer, okay, start with 0. That means whole world is start with 0, nothing. And then this is your, this will make a call to your kernel. Okay, kernel will become 1. Kernel will make a call. I'm just at a high level, I'm telling you. Kernel, let's say user 1, user 2. So here it will become a 2, here it will become a 3. This user 1 will run Apache. So this will PID will become a 4. Now you kill this 4 Apache, then 4 will be released, but it will not be utilized. Again, depends on the Windows and Linux concept. So likewise. So this is all mapping happens between the PID 0, 1, 2, 3, 100, 500, 600. Now how many process I am having running in my Windows? You look at this, start with the 0, end with 26,000. That means I think I rebooted my machine yesterday night. So from yesterday night till today, I have run 26,000 processes. Okay, please understand this. So that means every applications you will run, it create a process. Okay, it create a process. So that process here also Linux, you must see that these are the process. These all are application running in Linux. And you see I run this command ps-ef just before this. See, this is also process. Everything is a process, and everything is a process, and everything is required RAM and memory. Okay, so here PID. So everything you are running, you'll get a PID. See, 1 2 3 4 5 6, all like this. This will be keep growing actually. Okay, and you see start. So this parent for 1 is 0, parent for 2 is also 0, but 3 is 2, 4 is 2. I showed you know this image. The parent for this one is this one, parent for this one is this one, likewise this one is this one. Are you understanding, all of you? So this all coming from the PMAP. So one PMAP is attached to your kernel. Are you understanding?
Yeah.
So here, that's what I am talking about, the processes and thread. Okay, so what process? Same process which I have shown you. So everything you want to run, it create a process. Simple. Without a process, it is not possible. So process ID, and every process you have a one unique ID. You just now show that. Okay, and process will have a multiple thread. So what is process? What is thread? We need to understand that. So here you look at this. In order to run any application assign the PID. I showed you get PID through syscall. If you remember previous slides, get PID was a method in a syscall API which was getting the PID. So everything you run, you get a PID, and PID will have a multiple thread, and process will get a CPU and RAM allocation, and which process will share the CPU and RAM to all the thread. What is a process? What is a thread? We'll discuss in a detail in some time. So this is what it happens. So now if you see that here, this my image, let me show you. I'm showing you Windows again and again because you will be able to correlate. It's the same thing is happening in Linux also. So see here. Now if I want to know, hey, how PowerPoint, how many CPU you are consuming, how many RAM you are consuming, so what you will query? You will say, hey, get me the CPU allocation of PID 308. You will not say PowerPoint.exe. Okay, so you'll get me the, so see, this PID is linked to the user, this linked to the CPU allocation, this linked to the RAM also. So that means this, if I want to know how much CPU, how much RAM, all this thing, so this is the PID. So first thing what happens whenever you run any applications, it get one PID, and PID ask through the resource, through the kernel space, all the resources. Okay, so this is how it happens. So what is the process then? So I showed you all this thing at a high level, but the definition you should understand. A process is a computer program under execution. That means process is something when your computer is in running state. See, this process, if I kill this program, okay, understand that. So PID will be released. If I kill this program, PID will be released. That will not become a process. That's gone. But process is under execution, under running. Okay, so process is a computer program under execution. Linux is running many processes at any given time. In Windows also same thing. We can monitor them on terminal using ps command. I just now showed you, or the system monitoring UI. UI also I showed you for the Windows and Linux also. Linux processes are isolated and do not interrupt each other execution. What is the meaning of it? So here Linux program, let's say this program and this program, I don't know what exactly running, but these are the built-in program. So these all processes are independent. That means 13 will not disturb 14, 14 will not disturb 13. These all are independently running and requesting the kernel for the resources. Okay, so that is important. So process, what is a process? Every program you run, it get PID, that is a process for getting the resources. Okay, are you understanding, all of you?
Yeah.
Okay, so here with the PID, we can identify any process in Linux ps command. Internally, the kernel uniquely allocate this number and release it to reuse it after the process exit. Okay, so I told you 26,000, you saw that because of that reason only. Since many processes are running at given time in Linux, they have to share the CPU. This is important. Second paragraph is very important. Okay, I uh, uh, half an hour back I said this to you also, context switching. So since many processes are running at any given point time in Linux, they have to share the CPU. The process of switching between the two executing process on the CPU is called process context switching. What is happening? Let me show you visually so you'll understand easily. I don't know, my screen is sufficient updating it or not, but can you please confirm me? Are you noticing somewhere here, somewhere this part? Just notice for a few seconds and do let me know what is your observation in the CPU column, first few lines. Are you noticing something?
Yeah, the CPU count changes.
Something more?
The processes are getting killed so that CPU is
No. Process are not getting killed. I'm not killing any process right now.
okay.
See here. Look at this
The
clearly.
memory of the process keeps increasing and decreasing.
Memory or CPU? That is a natural, no? That is natural. See, guys, understand this way. Very simple. There is one thing called running. Running. In order to run applications, you just need a RAM. Okay. See here, RAM. You see, RAM. Most of the applications you have a RAM. Okay. Now, in order to run any application, you need a RAM, but you do not require the CPU. That is interesting. Look at this. 0, 0, 0, 0, 0. So what application I'm using right now? So I'm using GoToMeeting, which is right now I'm showing my screen. So that's the reason you see here few applications only I'm using it. So between these applications I'm using, see, running versus using, both are different thing. So when I use, I send the instruction. So for instruction you need a CPU. For running application you don't need a CPU. Look at this here yourself only. You don't need a CPU. Still it is running, but I'm using this application. So I'm sending some instruction. I am means GoToMeeting is always every millisecond sending some instruction. So this is switching actually. So first time GoToMeeting is getting CPU. After that, this one is getting switching like this. Are you able to notice now? See here. Got it? Hello?
Yes, getting it.
Yeah. So CPU is getting switched between the processes. I repeat,
So
CPU is getting.
when there is no count, when it is zero, okay, it starts with 0, 0. Okay. Yeah.
Yeah. So I'm running only GoToMeeting and Firefox, correct? So it's switching. That is what I'm trying to say here. Second point is very important, and this is an interview question. Okay. So here CPU, since many processes are running at any given time in Linux, they have to share the CPU. Okay. So what is happening? Same CPU you have to use. So what is happening? But CPU cannot allocate it to multiple process. So what is happening here? CPU is switching actually. So first time, and see, for our discussion, it's look like it's very slow thing, but it will be very fast. You will not realize that CPU allocations will happen so fast. You will not realize that this one which you see, it's very slow. I mean, we are seeing the very slow motion. More than 1,000% of the speed you will see then the context switching actually. So what is happening? The process of switching between two executing processes. Executing means executing the one which I'm GoToMeeting I'm using, browser I'm using. So the process of switching between the two executing process on the CPU is called process context switching. Interview question. They'll ask you what is a process context switching, or they will ask you simply what is a context switching in the kernel. So you say, hey, we have applications we want to run. So the moment you run the application, the process ID get allocated. That means every applications you run, you have a process ID. Process. Every application you call it a process. Now you need a resources in order to run any process. In order to run any process, you need a resources. What resources? Memory resources. You need a CPU. You need a disk. So for disk, they'll make a syscall. For RAM also, they'll make a syscall. But CPU also they'll make a syscall, but CPU cannot be allocated at a time multiple processes. So what is happening? Memory can be allocated. So CPU cannot be allocated. So CPU, what happens? Each process get a CPU at a time, and this process for switching the CPU from one process to another process is called process context switching. Okay, so this is important. Are you understanding so far? All of you?
Yes.
Okay, so now next question is, you know what? Think simple. Let's say in this my example, here CPU is switching from the Firefox to GoToMeeting and GoToMeeting to Firefox. Understand this way. Okay, this is happening. So don't you think whatever I did in the Firefox, it should be stored somewhere? Because if it's not stored, then you will lose the data. Let's say I have opened multiple application. You see here, many applications I have opened. So it should be stored. All these things should be stored. Then move the CPU to GoToMeeting. And same thing, GoToMeeting also. I'm showing you my screen through GoToMeeting. So it should store somewhere and then it should move to the Firefox. Correct now? Correct now?
Right.
And this is happening at the very tremendous speed actually. Very high speed. You won't be able to visualize also through your eyes. So what is this I'm discussing? So understand the third paragraph, which is very important.
So when it says 88, when the CPU says 88, does that mean that it's waiting in queue, or
Which one?
a system idle
Oh,
process is
80 80.
stored?
This means this much of CPU or there.
That
This percentage actually. That's a percentage. That means my whole system idle process taking 88% of CPU. But if you are running Firefox, it will take 6% of CPU. GoToMeeting, I think 1% of CPU. Okay, that's a percentage. Okay, so now next question, what I'm trying to say. So this each process when the CPU get my transferred to other process, then the previous process, everything whatever you did, let's say notepad, you write some code, so you have to store. It has to be stored. OS has to store, right? So what to do? So look at this third paragraph, is very important. See here, process context switching is expensive. Expensive means because the kernel has to save old register and load current register. Now what is the register? So register basically whatever the state of applications, this is called register. Okay, this is a whatever the state of Firefox I access at that time, it has to be stored. GoToMeeting also has to be stored. All this application also has to be stored. So that is called registered in the kernel. Also memory maps and other resources. So what happens? I'll tell you here. So we still say though, say like our system is slow. So what happens? Here you were using Firefox, it's stored. CPU got allocated to GoToMeeting, then it's stored. Again CPU got allocated to Firefox, again stored. This again switch. So this is happening in the loop. So because of storing everything, it takes few microseconds, lesser than microseconds. And that is the reason we call it is expensive. Time is expense right now. Time is everything. So this is called. So how do we solve it actually, this problem? So far you have understood about the process story, all of you?
Yeah.
Okay, so the problem is when we do the process context switching, then it is expensive because it takes some time to store all of your current state of your application, which in a technical word we call it old register, load current register, memory maps and all stuff like that. But how do we solve it? And that is where the thread is coming, the concept of thread. So what is the thread? So thread is also lightweight process, but a process can do more than one unit of work concurrently by creating one or more thread. So these thread is being lightweight, can be spawned quickly. Okay, so now thread is also kind of lightweight process. Then you'll say, what is the difference between the thread and process? So see, understand this thread. I'll put it in a one image so you'll understand in an easy way. See here, there is a one process here and there is one process here. Now CPU will be first allocated to here, and then whatever you happen here, it has to be saved. Then again here, and then again whatever happened, it has to be saved. So now between the process, it is waiting time few microseconds we have it. Okay, that is not good. So in order to optimize this, what we did, what scientists did, this process we created thread 1, thread 2, thread 3, thread 4, thread 5. Now guys, these all concepts are very important for you. I'll tell you, once you are doing the observability monitoring and all, you will work on this level. Okay, so please mind it. Operating system you need to understand very well, more than earlier we were not focusing on the operating system, but now with the CNCF technologies we have to focus. Okay, coming back to things, this is the process and multiple threads are there. So that means one process can have a multiple thread. Now what happens, understand this way. Earlier, when you get a CPU, this CPU is shared between the 6th and 7th thread. So that means you are able to get all this work done without process context switching. That means you don't have to wait for this many seconds. So this CPU can be shared between the thread in one go, and all this thread can run independently. Sorry, without I mean, it cannot run independently. It has to be a process, and it can run, and then your applications will be processing faster. So to avoid this expensive context switching timing, now programmers are designing process and will with a multiple thread which can consume the CPU and process the more things in a very short span of time before process context switching. Are you understanding, all of you? All of you?
Yeah.
Yeah. So how to see the thread? So let me show you how. I don't know how many threads we have. So these are the process. Okay. So these are the process, PID, all these things you see there. But there's one command in Linux, ps-elf. See here. So how many thread you have? So look at this. This is the one. So LWF, N means number of thread. So, see here. Okay. Uh, I mean, by luck, I am running Jenkins because of some session yesterday. So here, 48 thread. Just imagine this Jenkins has 48 thread. Now, if you are running as a process, it required lots of CPU context, I mean process context too, and the system will slow. Now 48 thread, it can share the stuff. See here, thread. These all are thread. These are 9 thread, 1 thread, 5 thread. These all applications. Okay, so now let's discuss about the thread. So thread is a lightweight process. Again, each thread will run certain application. A process can do more than one unit of work concurrently by creating one or more thread. These threads, being lightweight, can spawn quickly. Let's see an example, and you can run this command ps. Just now I run it to show you that. So PID, unique process identifier, LWP, unique thread identifier inside a process, and NLWP is the number of thread in a given process. Okay, this is the example I showed you. Okay, so any thread created within a process share the same memory. Remember that, it's important. Why we create a thread? Any thread created within a process share the same memory and resources for the process. So in a single threaded process, this process and thread are the same, as there only one thing is happening. But multi-thread, so threads share the same address space of the process, therefore spawning a new thread within a process become a cheap. Cheap means that waiting time, the one which I talked about it, is reduced. Internally, the thread has only a stake in the memory, and they have a heap memory, process memory with the parent process. So this is something which you have. I'm just showing you these slides. This is for the interview. So they will ask you what is the difference between process and thread. So process is heavyweight, thread is lightweight. Okay, process has its own memory, whereas thread share the memory which is allocated to the process. Mind it, thread share the memory with the parent process and other threads within the process. That means thread share the memory, but each process has their own memory. Now third line is very important. Process inter process communication is slower due to isolated memory. That means if you have multiple process context switching is slower, but thread, it is faster due to the shared memory. Okay, inter thread communication is faster due to the shared memory, and few more differences. Okay, so please remember these 3 points, that should be sufficient. These are the more descriptions. Okay, so now this is something which we have in Linux kernel. Okay, so any questions so far, all of you? Any questions? Hello, I'm audible, right?
Yes, you are audible.
Yeah. Okay, so just revise this one more time. I'll tell you, for the interview perspective, I think 2 questions is very important. 3 questions maybe. First thing, what are the space we have in kernel? So you should answer kernel space and user space. Second question, they'll ask you follow-up questions. How the resources running in the user space is, requesting the resources from the kernel space. So you should call it syscall. Okay, syscall is a kind of APIs. Third questions, what is the process and what is the thread and what is the difference between that? That's the 3 important question. Then again, if you are trying for the FANG companies, FANG means Facebook, Amazon, all kind of things, they'll ask you more questions. But at a high level, these 3 questions are very important in terms of Linux kernel topic. Okay, so now next things which I'm trying to help you is I'll go through this uh, containers. So before talking about the commands and all, I want to show you that high level the container worlds. Okay, demo based. This will not be discussions. I'll do that tomorrow, but I'll show you the demo on the Docker front. Okay, at a high level. So let's have a 15 minutes of break, and once you come back from the break, grab your tea, coffee, rest room, and personal calls. Once you come back from break, I'll teach you the Docker containers. Okay.
Have any issues with our channel membership, you can drop an email to us at contact@devopschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest.
Thanks for watching.